All right, there were, as you know, as always, 2, 3, or 4 quizzes. So I'll do a few out of each one. Sir? Yes, you may. All right, I ask you for an influence line for the vertical reaction at D. The thing consisted of 2 chunks of steel with a big old pin. A couple of you did it the long way, I think, by putting a 1-pound load here and solving for the resulting reaction at D. There's not a thing wrong with it. That's the basic, true way to work them. But it kind of takes a while to do it that way. I think a lot easier is if you want the reaction at D, you simply take the reaction at D and you move that up a unit amount. That way you're sure to at least have one number right on the influence line. When you move this horizontal piece of steel up 1 at that point, it rolls about this pin. You can forget about this piece right here. You don't even have to attach it if you don't want to. And if you move this one up 1, since this one is further from the rolling point, it will go up further. It is a straight line, and so this unknown height is to 10 plus 8 plus 12. This big triangle is similar to this small triangle, as 1 is to, and so you say this is to that as this is to that. You solve for the number, 1.5. Then this is also a similar triangle, this little one on the right-hand end that rolled down. So to get this unknown number right here, you say this height is to 6 as this height is to 20, and solve for the height. Then to find out what this piece of steel is going to do with his life, you'll notice it's still sitting horizontal where you took the pin out so that you could raise this thing up in the air. That pin still needs to be connected to that end of the member you rolled, and so you simply roll this up the 1.5, put the pin back in, and then to solve for this height, you say 1.5 is to 10, as question mark is to 5. It's half as far out, so obviously it has half the magnitude, 0.75. Then I ask you for the influence line for the shear at point C in the same, no, this one's rolled around, this one's pinned over here on the right. And so I took it home and I put it on the curb and I ran over it with my car and I put a unit kink in it. And that is the influence line. It's not properly positioned yet. You still got to bring it back to the job site and connect all the pins. When you do, you notice that pin B fits nicely, but the pin at D is stuck up in the air at a unit kink. And so point D's pin has to be rolled down so it'll still connect to the pin. That means this point rolls down 1. This point is also going to roll about point B, and it's going to roll down. It used to be at a number 1.0. However, since it rolled down, not as much as this guy rolled down because he wasn't as far out there, he rolls down a smaller amount. Roll down is to 8 as roll down is to 20. And you saw for how far from his original height the one he rolls down 0.4. Just like this point right here rolls down 0.4. 1 minus 0.4 puts him at 0.6. Some people just like to calculate this one right here, let it roll down, and then make the total length of this kink 1, puts it at 0.6. And then you can get everything else the same way. This 0.6 is to 12, as this unknown height is to 10. And solve for that height. And this piece goes with this pin, and this 0.5 is to 10, as this unknown height is to 5. It's obviously half as far out, so it's half as big. Yes, sir?
How do you know to start your influence line generator on like 0 at B or at A to B?
You don't. In other words, here's what you have when you start. And I'm not sure this will be the same as the one you just did, but just for an example. Then let's say you were asked for the shear at that point. Then you take that home and you kink it a unit amount. And it has a pin here in the thing you took home, and it has a pin here in the thing you took home.
Can you go from the right to left?
Well, if you don't go from the left to the right and kink up, your influence line is upside down. And it'll make you think that you should be putting loads in places where you shouldn't, and vice versa. Otherwise, in other words, if you don't kink it up and to the right, and if you wanted the moment here, if you don't kink it down and to the right, if you don't put those kinks in there, see, the reason is that causes a positive moment when the thing is put back on the supports. And this causes a positive shear when it goes back on the supports.
Okay, so if you went right to left, you would go that you kink down?
That's correct. That would work just as well as you see. If you went from right to left, you'd have to kink it down. Now then, as far as putting it back on the supports, there must have been another support in here, so let me put another support. There's a pin, and there's a pin. It's up to you. You are more than welcome to take this pinhole and put it here and let this one come out wrong. Thank you. You're more than happy to take this, and when you get on the job site, you put it here. And so then the structure now looks like this. Looks like this, looks like this, looks like this, and it looks like this. Me, you know, I always seem to take mine and I put it here, and then let this one not be connected. And then I roll it down and I connect it. But you can do the same thing. You can do it this way, and you can say, look at this, this is 1 below the line. I'll have to roll this up to get that pin connected again. And when you do, this one will roll up, and this one will roll up, and this one will roll up, and this one will roll down. Whereas if I brought mine out here, let me be the X's and you be the wiggly line, here's where I would start mine. And I would put my pin in there, and then this pinhole wouldn't fit on that thing, and I would roll mine down. It would fit right on top of yours. In other words, it's a rigid body translation, so it doesn't make any difference where you start, because they're both going to end up looking exactly the same. All right. Second, shear influence line. The other one, you know, is going to be done exactly the same, and it's posted out there. I told you that this was an influence line for shear, for the beam shown. And I told you there was a dead load of 3 kips per foot and a live load of 6 kips per foot. I told you in class, several people came up and asked and said, can you put the dead load only where you like? And I told you, I don't know. I never did understand that stuff. Some of you asked me, did the live load have to go all the way across the beam? I said, I don't know. I don't understand that stuff. You know, that was the idea. Dead load has to go everywhere. It's the slab. There's no way to get it off of there. If there was, we'd take it off because it just causes problems. The live load should only go over the area that you're trying to find. If you're trying to find positive shear, you'd look under the positive areas. You put the live load here, and you'd put it here. This particular exam, I ask you for the maximum negative shear, so you should have put live load here, and here, and here. And then all you have to do is, in effect, find the area of a volume where this is the side view and these are the top view. It's also like integral of mmdx over EI. There's no EI involved. So this guy is 16 feet long. He's a negative 0.8 in magnitude. Then he is combined with these two loads. There's a 3 and a 6 because we have both the loads in that area. And then that area is, because it's a triangle, it's a half. So the shear at B, just due to these loads, is negative 57.6. Then here's some positive that you couldn't get rid of. 0.2 times 4 times a half. There's 0.2 times 4 times a half. And then times only the 3 kips per foot, because there is no live load in that region, because it detracts from this worst case number. And then you simply add them all up. And again, these are all posted. All right, let's go to the other quiz. Yes, sir.
I have a question about the first problem we went over. Can you do how to get, if you do the moment at E, how you get that
Sure,
value?
sure. And that is a good point, because that one was different on the other exam. Well, got to be in here somewhere. Here we go. Here's the one for the moment. What I did was I took this straight piece of steel home. I was asked for the moment at E. There was a pinhole in the original piece of steel here, a pinhole right here, and a pinhole right here, where the pins used to connect. I was asked for the moment at E, and so I put a 45-degree kink in the structure, turning it into its own influence line. This distance from the kink to the pin is 12 feet, and since that's a 45-degree angle, the pin has now been moved down 12 feet, and this part of the structure no longer exists. And so all I got to do is come put all this back together. You do it in any way you like. To me, it seems easiest to put the influence line right here, beep, put the pin in there, put the influence line right here, put the influence line right here. Sadly, at that time, you didn't hear a beep because the pin doesn't fit. And that's the influence line, but not properly positioned yet. And then you simply roll this point back up to the pin, namely 12 feet. Once you roll this piece up 12 feet, this point 12 feet, you're rolling it at about point D. This point E is going to roll up also. However, it won't roll up as high as this one moves up because it's not as far from the rolling point. So what you say is point E rolls up as to 8, as point F rolls up is to 20. So point E rolls up, since he's 8 feet out, as point F rolls up, that's a 12-foot roll, is to 20. And you solve for how far E rolls up, 4.8. Then point C, once you have this line here, of course, and that also gives you this line, you're pretty much through, because everything else now is similar triangles. 4.8 is to 8 as question mark is to 10. Solve for that number. 6 is to 10 as question mark is to 5. Getman, did you get a quiz? Anybody else come in excessively late and didn't get a quiz?
It's the last day, you know, I got a good tradition of it.
I don't know why I pick on you.
I don't blame you.
I get a lot of good answers from you when you're here, so. All right. You want to push that a little further? Is that,
Yeah, that's good.
does that make sense? All right. All right, let's do this one. Now, there were two ways you could do it. Number one, you could draw moment diagrams for the various loads, the unit loads and the real loads, and then with those you could use volume integrals. The second thing you can do is you can do equations. And I'm happy to grade the equations, but you got to tell me, you can't just say the equation is x squared minus 1600 integrated with 43 e to the ln of gx. You know, I don't know what you're doing. I have no idea. First place, I'm pretty sure the equations aren't right, but I can't even give you partial credit because I don't know which range you're trying for. Is that for this piece? Is that for this piece? This piece? 1, 2, 3, 4. There's 5 pieces there. Did you, I hope, tell me that you were going to call that x as opposed to calling this x? So now that I got 1, 2, 3, 4, 5 times 2, I got 10 things I'm trying to figure out why your answer doesn't come out right. Your integrals are beautiful. Now they look like this. So they have the little wiggles on the end, and, you know, and I can read all your writing, not all of them, but, and I'm willing to talk with you too. First off, I look at the answer. And if the answer's right, man, my life's too short. I put a check on it and move on. If you got it by accident, I figure that you'll get the right answer on the 40-story building you designed 20 years from now. You'll get it right too, just by accident. When I get an answer that's wrong, well, then I go back trying to figure out what went wrong. First, yes, you may. Name? Well, I think you were the last one in there, I remember. Anybody else? Are you sure? Nobody else. All right. Now, you know me, I'm lazy, so I think it's easiest to draw the moment diagram and then use the volume integrals. I'll tell you, if you're using these equations, I really recommend you draw the moment equation and then get the equation off of the line. I think you'll have a lot better luck at it. If you say my equation started from here, x went this way, and the moment in this region was 2 times x over 2, and I just missed it and counted off 30 points, I'll be glad to discuss it with you. I really will. I have no use for those points. They just clutter up the closet. Nobody pays me for them at the end of the year. And if they're yours, you got them coming back. Basically, I ask you for deflection at location or position number 4 due to the real loads. So first, I need a set of moment equations or moment diagrams for the real loads. Starting off, there's nothing connected, nothing connected, nothing connected. Now we start to pick up some load, so the moment starts to get bigger and bigger and bigger. The load is a uniform, so the shear is a straight sloping line, so the moment is definitely a parabola. I know the moment on the end is 0, and I didn't put any numbers on it. The only number I put was at the end, because I really didn't know what I'd need later on. So I drew a parabola, and I'm not even sure. I might have drawn the first parabola wrong. I'm not sure I worried too much about it until I got further into the problem. The moment at this end is 2 kips per foot times 40 feet times the distance to the centroid, which is 20, came out 1,600 kip feet. And I guess I did too. I guess I did do the value in the middle because I'm used to having to have a value on the end, a value in the middle, and a value on the big end in these volume integrals. So I got the moment here, and that was 2 times 20 times the distance to the centroid is 10, 400 kip feet. Turned out later on I needed one in the middle. Not a problem. That's 30 feet down times 2 kips per foot. That's 30 times 2 is the load. The centroid of that load is 15 feet away. Now then, as we go down this side, we have a load. Take all this load and concentrate it at its centroid. Multiply it times the moment arm, times the moment arm, times the moment arm. Constant, 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 constant. It's 1,600 on that side of the corner. It's 1,600 on that side of the corner. And it stays 1,600. And I need to combine that. Yes, sir.
What if you selected a different primary structure?
But you can't. Well, you can. And I won't like you a lot, but I will consider that you did that. But you see when I say for the structure shown, and you see these big old redundant R's hanging out, the primary structure was free hanging to the wind, free hanging to the wind, stuck up in the air, and connected to the ground. You connected it at the top just to aggravate me?
I guess I didn't notice the bottom one. So
All right, then, now let me see if you could have got an answer. Yeah, R0 would have an answer, and R46 would still have an answer. Now, did you get the right answer for R46? Because no, it won't be the same. No, because the loads all go down here. You'll have to, don't change anything, but you'll have to bring it to me and see. I'll work with you on that. All right, the second thing I need, since I've asked you for the deflection in the number 4 direction due to the real loads, I've got to go put a 1 right here and draw the moment diagram just due to that, all by itself. On the primary structure, here it is. With a 1 here, everything else is 0. 1 times 0, 1 times 1, 1 times 10, 1 times 20, 1 times 30, 1 times 35, 35. Tension side of the member. Go around the corner, stays 35. Go around the corner, it stays 35, it stays tension on the outside. And as you get to here, the moment is trying to go back again as it was back to 0, but the structure stops 15 feet over, so the moment right there is 1 times 15.
Is that like a triangular?
It's a trapezoid. It would have been a triangle had there been a longer piece of steel.
So no matter what the structure, the moment is always going to be 0 at a cantilever support?
No, the moment's not 0.
Oh.
Wait, I'm sorry. See, the cantilever part is here, and the free end of the cantilever is here with a unit load on it. So the answer to your question seems to be, is the moment at the free end of a cantilever beam with a concentrated load on it equal to 0? And the answer is yes, because right now the 1 doesn't have a moment arm. All right, so here we go. We're going to combine this with his buddy on the previous page, this with his buddy on the previous page, and this with his buddy on the previous page. There's a triangle, a rectangle, and a trapezoid. The triangle goes here, but there isn't one on this one, so that integral will be 0. The uniform will go here with a piece of a parabola with 3 points on it, and the trapezoid will go with this uniform. So we're going to combine a parabola, 4, 9, 1600, with a uniform, 35, and we're going to combine a uniform of 1600 with a trapezoid, 1535. 1535. And you go look those up in here. The parabola is LA onto C plus 4D plus E. If you don't know which is the C and which is the D, doesn't matter, because they're both multiplied by 1. And then a L is 20 feet times C is the 1600 with an A plus B. There's your A, there's your B. If you reverse them, you get the same answer divided by 2. You simply carry out the operations. Now, I'll tell you the truth. There was a lot of number work going on there. And I told her, look, if you spend over 40 hours grading this thing, she graded it first, as you know, and then put this one last. Check them to see if they got the moment equations or the moment diagrams right. Check them and see if they got these things right, that they look like they're trying to use the proper volume integrals. And if you get down in here, it's a zoo, just say, okay, like you think it's right, and I won't grade it either. So in other words, oh, I graded yours. Oh, yeah. Oh, I graded everything on yours.
You said okay on mine, and you graded it.
Oh, yeah. Oh, yeah. Oh, yeah. Oh, no.
I got minus 10 too.
Well, let me tell you, it's not because you have errors in these numbers here. It's you did something up in here. Now, having said that, I'll take a look at your paper, but I won't give you back any points. And I'll look at your paper. But I promise you, because I know I didn't get in there and try and find out in other words, if you got this right and you got this right and you got the wrong number in the box, I didn't look at it. I didn't care. Because I figured you were close enough. I wasn't going to get any more than a point or two anyway. It wasn't worth it. So I will look at yours. However, if you got points for something else, you better hope I don't see something else I missed. No, let me see it. I really want to know. All right, the other thing is I asked you for the deflection 4-6. So I needed this guy, and I needed this, a unit load in the number 6 position, which caused tension on the outside of the structure all the way around back to the ground. So we're going to combine a triangle with a uniform with a uniform, and a trapezoid with a uniform. And these are all one, so they shouldn't be hard to remember. Here's our triangle, 35 with our uniform of 1. Here's our 35 uniform with a uniform of 1. And here's our trapezoid with a uniform of 1. LAC over 2, LAC, LA on to this guy plus this guy, average over 2, and it gives you the answer. Questions on that one? Will there be one of those on the final? I mean, you can almost guarantee it. I mean, this is, all the other stuff is good stuff. Portal method is good stuff. Finding out where to put the wheels on a thing to get the maximum moment, that's good stuff. But the real underlying thing this course is for is to solve for forces in statically indeterminate structures. And that's the way you do it. Slope deflection is good stuff, but it isn't near as powerful as what we're doing here. All right, let me find something else on the second quiz. So we worked something out of both of them.
Are you going to show the other one on the other page?
I can, sure. Hardly any.
There's not a big difference, but I just want to see.
All right. There's no difference in this load. Okay, in other words, the moment diagram for the real loads is this one for both cases, for both quizzes. Then I asked you for deflection 1, 0 as opposed to 4, 0, which means that you put a 1 right here, and here is the moment diagram. It looks exactly like the moment diagram you did before. The only difference is in this one, the moment came out of here and went around. This one, the moment diagram, the moment comes out of this top piece. Instead of going up here up to a value of 35, 35, 35, this load now was out here 10, 20, 30, 40, 45, and therefore it's 45. Stays 45 around the corner. This load has a constant moment arm all the way down, 45. Moment stays the same around the corner, 45, and comes back 20. Which means he's 25 feet out. 1 times 25 is 25. Yes, sir.
Why would we assume that it's going to be, like, the moment's not going to stay the same in that lower member?
All right. Let me ask you this. Let's just look at this load and how far he is away from the point where I'm going to put my finger. And you'll have to kind of remember 10, 15, and 20, okay? 20, 30, 40, 45 feet away. How far away is that load from my fingernail? Say 45. Okay, and that's right. See, because 1 times 45 is what you got here. All right, now then if I move a foot away, the point I've asked you for the moment in this thing right here is 1 foot closer to the load. See how the moment now is 44? If you move back here 20 feet closer to the load, then that 45 is going to not any longer be 45. You're now only 25 feet away from the load.
But there's no load in that lower member directly. Like,
Well, let me draw it. There's no question it's confusing as much garbage as I've got on there. Let me draw it just like this, because this is the final say-so. There is a unit.
the reaction, huh?
It is the reaction. That's right. Right in here you might say it's not the reaction, it's really inside the beam, but right there it gets to be the reaction. The question is, this guy is 1 times 15 that way, and the question is inside of this beam, how much moment does it cause? And it's 1 times, I'm sorry, not 1 times 15, it's 1 times 25. Now, did that work?
Yeah.
Okay, and I think now you were asked, was this the same on both of them? Maybe it was.
1/6.
1/6, okay, well there's a 1 on a 6. All right. All right, so what do we not have done? This guy had a lot of people that wrote down maximum moment occurs in the middle of the beam. Sorry, but that is the case. If you have a single load, then you would put it in the middle of the beam. Or if it's a uniform load, it would cause a maximum moment in the middle of the beam. But for a set of wheels, turns out that's not the case. Do you get pretty close? Yeah, you get pretty close. I forget what you get, 704, 708 instead of 780. It's pretty close, but it's not the max. In order to find the max, first you must find the location of where you could place all the wheels as a single wheel, and it would cause the same external reactions were you to roll it across the beam. You do that by summing moments around one of the wheels. I sum moments about the left wheel. Some of you went around this one, could care less. 20 kips of load times a 10-foot moment arm, and another 20 kip wheel times 10 plus 32 is 42 feet. That's how much tendency there is for that set of wheels to roll about point F. If you were to replace this 20 plus 20 plus 5, 45 as a single wheel, it would go and cause the same tendency to roll about F. So that's equal to 20 plus 20 plus 5 times the location of that resultant. And that tells you at 23.11 feet, 23.11 feet from this point, that's where the resultant of that set of forces goes. Now we derived it. I didn't ask you to derive it on the quiz, but we derived the fact that anytime you have a beam and you have a set of wheels, and you know that the resultant of all those wheels is located at some point, it's your job to split the resultant and the nearest, biggest wheel and put that split point right over the center line of the beam. So I'm going to cheat, and I'm going to draw the beam like that so that it ended up being over the center line. That was your job. And then the maximum moment occurs under that nearest, biggest wheel. Now, one of you wrote, I don't know which is the nearest, biggest wheel, so you did them both. Well, that's okay. You can't go wrong with that. But both of these wheels are big. There's not a bigger one, so there's no choice there. And this guy here is obviously much nearer to the resultant. That's the one. So here's what happens on that problem. This dimension is 13.11, so you split that, 13.11, half and half on each side of the center line. And then you simply solve for the reaction due to the loads being positioned right there. And then you solve for the moment underneath the nearest biggest wheel. Once you get the reaction, that'll be that reaction times that distance minus this wheel load times 32. There's the calculations. Put a box around it, put a bow on it, turn it in. Is this an easy class? No, it's not. Those of you who are nodding yes, well, maybe for you. It never was easy for me. But did I have some hundreds on this exam? No, No, I didn't. Should I have had 100 on this exam? I think I should. Somebody ought to make 100. And so you can take the paper, the grade you have on your paper, and you can put +5 on it, because that's what I recorded. So I don't know who made a 95, and I won't embarrass them by calling out their name. I think that's one of the guys who didn't show up. No, I guess he did show up. Or she. I got a 94 here who didn't show up. And give it to you, right? It wouldn't go very far. All right. I want you to look your quiz over, and I want you to compare it with the posted solution before you come up. Really, you just don't know how aggravating it is when you come up and you say, I don't see why you took off 5 points here. And then it's so obvious, that it makes me feel like I should have taken off 20. Think about it. Consider it. Get your ducks in a row. Then when you come in, if you think you lost too many points or something, you can point it out to me. Or if I made a mistake grading it, absolutely, that's fine. Yes, sir. Did you have your hand up?
I did, but I'll ask later.
Okay, yes, sir. Why is it here as opposed to being in the middle? We'd have to look in the book and rederive the thing. What we really did is, if you remember, we put the loads on there in an arbitrary position. And then we said, okay, now what happens if we move? What is the equation for how much moment is being caused? And it was just an equation in terms of R1, R2, R3. And then we took the derivative of that equation and set it equal to 0. And we said, that equation for how much moment is caused is going to peak out. And we saw for where it was going to peak out. And it turned out that this moment, anywhere along the beam, peaked out when you would split those with the center line. Take a look in the book, and I'll be glad to show it to you. We'll talk to you about it again. All right, Getman, I'll take a look at yours, only because I want to see that. And I know you won't bring it to me otherwise. And I'll take a look at yours. And anybody, if I just flat added your points wrong, I'll take a look at yours. What are you nodding your head for? No, I don't believe it. I'll find 2 more points in there somewhere. Let me see. Wait, I got to find if I got I got a green pen. All right. All right. Any other questions? All right. For heaven's sakes, don't get killed. It's not, Thanksgiving is not worth that much. Now, I did regrade. Let me go ahead and just add points if I really... Who did I just not add your points on? No, I believe you. 4, 10.
Mine, and then on number 2, right here, I said, I knew that one wasn't right, so I said use the one on the attached page.
I missed it.
And I got that.
No, I didn't even look at it. Is it right?
Yes, sir.
It's my mistake.
That, and then the last one, I think I got double counted off.
Well, no, I can't help you there. The last one.
And I had only gotten down to a
All right.
70.
No. I owe you 6. There's no question. Let me get that behind us first. I need a piece of paper with your name on it and your new grade. I will definitely be in my office tomorrow. Yes, sir. I'll be here most of the holidays if you're around. All right, so 10, 11, 12, 13, 14, 15, 20, 25, 30. All right, so that adds up to this. Okay, now you're talking about
I had
double.
added up the points that you had circled in green or underlined in green.
See, here's what went wrong. I don't know why she said that's okay. She thought that was right, but that's not right at all.
These weren't the
Wait.
ones I used. I had used the ones on the next page.
Oh, you jerk.
those still aren't right, but
Oh, no.
There was less
No,
than
no. Yeah, those are. No, it looks like, no, I missed that page entirely. I never made it back there.
that's fine. I was just,
No, I'm sure not happy. All right. Okay, this you see is still wrong.
no, I understand that.
All right, so I'm still going to get you with that one. I thought those moment diagrams were much more valuable than she did, but I avoided any attempt to change that because in her opinion isn't really much less useful than mine. So, yes.
Okay.
And so this is gone and this is here. Well, that's what she counted off for that one anyway. It's just these that you got wrong.
Yeah.
And this one didn't have anything. That's why I really got you on that one. All right, so now then, 10, 12, 13, 14, 15, 15, 20, 1, 2, 3, 24. Do you agree?
That's fine with me.
That's not fine. You got to agree.
Okay, I
Check
agree
it.
with it.
Check it. No, check it. And then if I'm right, well, then put it down. All right, I asked you to stick around.
On that one, I'm not sure why I got it wrong.
I don't either. But see, here you are. I took off that many points because I thought you just did something dumb. But now you tell me you don't know why you got it wrong. Well, wait, let me put down your real score. If you don't know why you got it wrong, you owe me twice as much as that.
Well, I think I got it right.
Well,
That's the thing. I think I did it correctly.
well, now something's fishy here because I graded 60 of these things, and that isn't the number they all gave me. I don't think. Hold that. Which quiz number is it? 2. 2. See, that's what I told you not to do. I told you I would not discuss this with you. And here I am. Negative 7.6. I'm not going to discuss that with you. You go figure out.
Asking for the
You go figure out. Yeah, and there is no positive. It turns out it never goes positive. You probably could tell it wasn't likely to go positive with such little positive areas. I'm not going to discuss that with you. Where's the 2 that you think I?
Oh no, that's all correct. That's just the
All
only
right.
question that I had.
Okay.
Whereas the last, I'm missing 4 points.
All right. Did you get those
Got
2?
5 for no.
There's 2 for that one wrong. 2 for
Okay,
that.
that's okay.
That makes it okay.
Yes, sir.
Did you say that we all add 5 points to our exam?
Yeah, absolutely. The final number that you have on there. Now, see, I gotta be careful because you got a 76. So that's 81.
So I guess I should get a 88.
Did I give you 3 points? No. Yes, you got an 88.
Oh, so it's already added?
It's on the record sheet.
Oh, cool.
It already been put in there.
I did almost the whole thing correctly. I just didn't do it.
I'm not going to
the same
discuss
point.
that.
Okay.
I'm not going to discuss that. You go look at it. You check it out.
Oh, do you have points listings on the solutions online?
I don't know if there's point listings, but
Like, I know what I did wrong, and I understand that. Like, I
Yeah.
just approximated at the center line. I'm just curious.
if you approximated the center line, it cost you 10.
Okay.
It's not.
All right,
It's
that's
not,
all I was curious about. So
Yeah.
how much that was worth.
Yes.
All right, thanks.
Okay. What I did was, it's a stupid mistake, but I placed the 6 kids per foot live.
I'm not going to discuss these things with you. I told you.
No, I know it's wrong.
Okay.
You took off 5 for that for placing them in the wrong direction, which is wrong. But you assume that, well, no, okay, this turns out to be the dead load. But what I did was I took a resultant force between the live load and the dead load and got -3. So I didn't do it twice. See how you took out 5 points for the same thing? I really took a resultant force.
Well, that may be true. Let me think about this. I thought I already factored that in when I changed hers. Why in the world did you put live load
I
up?
don't know, that's dumb. I'm pretty mad at myself for that, but
Second on the
it's a
smart
pretty
sheet,
small
though.
mistake.
He listens to every word that you say in class.
All right, so let me think now. You're saying you have 6 Kipper foot shown.
Right. And then 3 down. So that's a resultant of 3.
Okay, and what did you put in here?
I put 3. That's right over here, the positive 3.
Positive 3.
Positive 3 for right there and right there.
Positive 3 times 0.2 times 4 times a half. And what did you put in here?
That's the second one down there.
That's this one. 3 times 2. The 3 is right, times 16 times a half. Okay, so those two terms are that. Then you put a minus 3. So you're going to pay for putting them upside down. And, man, I'm lost. All right, let me see what in the world you did here. So these two are right. Those two areas are taken care of. Those are no longer under discussion. The only question is this here. And you did put the live load in the right place, but backwards only. I see. All right. I never would have figured that out. Well, that isn't nice. I'm not happy about that. Give me a piece of paper with your new grade on it. Here, put it on there. Yes.
I wanted to take my test up, please.
Oh, okay.
Thanks a lot.
Okay. Name.
Skeleton.
Ooh, for crying in a bucket. You need a better prof.
I just
You
don't
need-
know more.
What'd you make on quiz A?
78.
Well, dang, that was good. What happened on this one? I thought it's a lot easier quiz.
I don't know, I'm just glad it wasn't a circle number. Wait, is it that one or that one?
That's the grade.
Okay, so what's
Here.
that one down there?
Nothing.
Oh, then that's not a good grade.
She grades, and then I
Go back and read
I
it.
trim them out. And believe me, I don't know whose grade whose quiz I'm grading, because I go through like this, and I start grading. All right.
Taking on all the mean people